Hello, let's continue our Advanced Sudoku series with Oddity by Shye. This is puzzle number 4 of chapter 6 of the Sudokult Gospel document. We're getting close to the end, but there is another chapter ahead of us. So per usual, I know what technique I'm looking for and how it works, but not where it is in this specific puzzle. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I want to start by penciling the border, I think. I think we're going to find some nice stuff on the border, just given where all the givens are. Given where the givens are. And then I might do some normal scanning, but I think we might be able to find what we're looking for. It looks pretty well telegraphed. So maybe I'll just do this row first. We need 1, 2, and 7. These aren't 7, so the 7 is actually here in the row. Yep. In this column, we need 2. We've got 3. We need 4, 5. We have 6, 7, 8. We need 9. Okay. I don't think any of that cleans up. Let's do this row. We need 1, 2. We've got 3, 4, 5, 6, 7, 8, 9. Okay, we need 9. 1, 2, 9. And then this column, we've got 1, 2. Sorry, we need 4 and 6. Okay. Cleans up pretty well. I've got a 1, 2 pair here, so that's not a 1. We end up with this 4, 6 pair here. Do we have what we need? So I'm going to start by looking at these cells that are all 1, 2, 9s. Let's just highlight them all. Okay, let's see here. Let's start with this. Let's get rid of these here. Let's not worry about these right now. We'll start with these green cells here. So what we're going to do is we're going to pretend that these 9s aren't true, right? So I'm just going to remove these 9s. So basically, this is a proof by contradiction, right? I'm going to prove that one of these 2 is a 9. So the way I'm going to prove that is going to say, well, what if they weren't a 9? Well, let's try to resolve this. I'll just pick one for this. 1 here. This would be 2. This would be 1. Oh, the problem is that this doesn't see that. Okay, I got to pick a different one. Sorry. It did not occur to me that these didn't see each other for some reason. Let's recolor these. We're going to do something similar, but maybe a different pattern here. How are we going to connect these? Maybe I'm missing something. Let's pencil these cells. 1, 2, 3, 5. So the 5 is placed in the box, actually. And there's a 3 in one of these 2. Is there another 1, 2 that links in this box or something? Or over here. What's left here? We need 1, 2, 3, 4, 9. I don't see anything super special about that. Three can be placed in this box, though, because we've got these 3s pointing in. This 3 looks in. That's not a 3, so 3 is placed. I don't know if we can follow up on that, but these are now down to 1, 2, 4, 9. I'm just going to fill that. I still think these 1, 2, 9s are key, but I need to make a loop. For some reason, I'm struggling with a loop here. Usually we'd use something like this pattern or this pattern to do it. I'm worried about this 2, 9 here, though. And how that fits in. It might be these, so... maybe we need all of these cells. Maybe we just don't need this one here. So let me actually, I'm going to pull up I haven't used my pen tool in a while here, but let's pull that out. So let's draw some lines here. Let's connect these. So I'm just going to draw a loop. Not worried about like specific notation here, but I'm going to show how kind of this can loop. We're going to skip over this one. I'll just do an arc like that to show, I don't know, does that make sense? Anyway, this one connects to that. We're not worried about this middle one here. And then to here, and then to here. So the question we want to ask is how many... I'm a little bit worried about this 2, 9, but let's find out what's going on here. So how many nodes are in our loop here? And the answer is we got 1, 2, 3, 4, 5, 6 nodes. 6 nodes is actually fine. So I need to draw it differently. Whoops, okay. In fact, I had this in, but I don't think this is helpful. So we're going to remove the green. That'll help. Yeah, 6 is no good. We need an odd number length loop is what we're looking for. And I feel like I'm not doing this right. I wonder if there's just more Sudoku I'm supposed to do first. I'm looking real quick to see if there's anything obvious I see. I'm not seeing much. Doesn't mean it's not there. Okay, so what are we doing with this then? Is it just this? Because this one isn't connected to anything. Do we need to use all of these? Can we use all of these? 1, 2, 3, 4, 5, 6, 7, 8. This is 8 nodes though. So we wouldn't want to use all 8. This was kind of my bridge to the bottom. We have this bridge to the bottom. Why am I not seeing how to do this? Yeah, it's kind of a mystery. Maybe I'm not looking at the right thing. Hold on. Let's see if we can pencil any more cells. Maybe I'm just missing an important cell that I didn't pencil. Let's see how much Sudoku we can get out of this puzzle. Just normal Sudoku. Already not seeing much, but this box here maybe? So what's left in this box? We need 1, 2, 3, right? And we got 4, 5, 6, 7. We need 8, 9. Yeah, that's no good. Over here, we need 1, 2, 4, 5, 9. So the 5 actually looks into here. 5's in one of these 2 cells. Oh, 5 is placed. Ooh, maybe that's helpful. This 5 looks down, this 5 looks in. And this 5 looks in. Okay, so 5 is placed. Does that help me? We know the 4 is in one of these 2 cells. These are from 1, 2, 4, 9. There's not much going on with that. So what's this column? What does this column need? 1, 2, 4, 7, 9. So the 7's in one of these 2. Yeah. 5 is placed here, actually. We have these 2 5s looking in. 5's in one of these 2 cells. 3's over here. 3's over down here, actually. That puts a 3 here. Okay, what else do we have? These are still a lot of digits. How about this row? We need 1, 2, 7, 8, 9. I'm going to fill that out. 1, 2, 7, 8, 9. Because this one's not 7, 8. So that's oh, we have a 1, 2, 9 triple here, actually. So this 1, 2, 9 triple means the remaining digits are 3, which only goes down there, right? 4. 6, actually. Yeah, this is the 6, and this is a 3, 4 pair. Okay, so there's quite a bit of regular Sudoku, which I didn't realize. We also have this 1, 2, 9 triple. So this is going to be a pair. 7, 8. We know the order. That's 8, that's 7. So this is from 1, 2, 9 as well. Okay. The 4 is over here. Might as well mark that. I've got a 1, 2, 4, 9 quad here. So this is a triple. I need 3. We've got 4. I need 5 and 8. Yeah, that's it. Okay. 3, 5, 8 triple. This is 2, 4, 7, 9. Yeah, because they can't be 1. So 2, 4, 7, 9. This one's not 2. Okay, I've got all these 1, 2, 9 triples that are super suspicious. Maybe we can connect this a bit better now. I think this would do something, but it's not. Let me just explain what I'm looking for, because I found something here, but I don't think it's enough to act on. We have it over here too. Well, let's go over this one first, because I think I can finally explain what I'm looking for here. So I'm going to connect these purples together. Ignore the greens. I'm just keeping them green for no reason. So we've made a loop here, right? These cells all affect each other in kind of this loop. The important bit is that we have a loop that returns back to where it started. Now, what we're going to do is we're going to be proving that one of these needs to be a 9. The way we're going to prove that is by contradiction. And the important bit here is that this loop has 5 nodes in it. So if I were to exclude 9 entirely, look at how this would try to resolve. I mean, I guess we already know that 9's in one of these two, by the column. But anyway, let me explain. This is not where we're looking for it, I suppose. But anyway, how would this resolve? Let's just pick a digit for this one. 1, 2, 1, 2, nothing, right? Because it's odd length, you won't be able to resolve. It can't be colored, right? It can't be colored with 2 colors. That's the whole point. If I were to try to use 2 colors to color this, like let's say I pick blue and orange, right? Blue, so these 2 would be orange, and then the oranges would see blues, and now I'd have 2 blues in the column. So you can't uniquely you can't color it at all using 2 colors. So however you want to think about that, we know for a fact that 9's going to end up somewhere in here, and those are called the guardians. They're guarding the loop from making the puzzle invalid. Now, in this case, that's not super interesting because we already know 9's one of these 2 by the column. So we're going to have to get a little bit more creative with where we're finding this loop, but I think it's going to be related to these green cells and the 1, 2, 9's. Let's clear out the lines here. So I want to try to avoid using this 2, 9 here, unless we're trying to prove that 1 has to be in the loop, but I don't think how that's helpful. We do have this 1, 2 pair up here, and then we've got 2, 1, 2, 9's down here. I don't know if that's helpful. Using this or this is probably key, just because this formation that we have in the boxes allows us to sort of turn the corner and make an odd length loop. So let's see, like what happens if we do something like, I want to try to avoid using, so here's what I'm thinking. Thinking of avoiding using this one here, so that then we could prove that the 9 has to be down here or something like that. That might be helpful because we could make like a 1, 2 pair in here or something. So like if we can prove that, like let's make this link here. What we're trying to do is we're trying to avoid using this link, and we're trying to make an odd length loop. So for example, we could do this. This would be an even length loop, so that would be okay. We could go here, and then we could go here, and then we could go here, but then we're going to have to include this one. If we included this one, how many, 1, 2, so if I highlight the nodes I actually used, I used this one. I did not use this one. It's not helpful, but 1, 2, see, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 long anyway. So that's not helpful. I'm missing something. I feel like it's supposed to be standout obvious here, but it's not to me. I don't know. Is there more Sudoku that we can do? I missed something about these 1, 2, 9s. We know one of these two is a 9. That's just column logic. We also know one of these two is a 9 by row logic. Where might I not have looked yet? Like, what's this box need? This box needs 1, 2. It's got 3, 4, 5, 6, 7. It needs 8, 9. So that's another 1, 2, 9. The 8's in one of these two. Here, this column, we need 1, 2, 3, 4. Not 4. 1, 2, 3, 6, 9. Okay, this can't be 3 or 6. We have another 1, 2, 9 triple in this column. And so the 3, 6 ends up here. Yeah, okay, I didn't see the 3, 6 hidden pair, but I mean, until now. Eventually saw it. So these are from 1, 2, 4, and 9. Three, 6 pair. So this 1, 2, 9, is that helpful? Okay, maybe there's just more Sudoku still. These 1, 2, 9s are super suspicious. They're all over the place. This column, we need 1, 3, 7, 8, 9. The 7 can only go here. We have this 7 and this 7. So we can place the 7, place that 7. Okay. So here we need 1, 3, 8, 9. It's not a 3. Here we need 1, 5, 8, 9. I think I've got almost everything penciled. Might as well pencil this one. It's 1, 2, 3, 8, 9, right? It's any of them. Okay, so what did we learn by penciling all that? Okay, I'm gonna highlight all the 1, 2, 9s again. Any cell that's down to just 1, 2, or 9, or some subset of that. I think it's these ones. What would we be trying to prove here? The thing about guardians is you have to pretend they don't exist when looking for the pattern. Because we're looking for a pattern. The aagon is a pattern that can't happen. It's impossible to happen in a Sudoku with a solution. So you're not going to find the pattern. You're going to find almost the pattern. And then that almost is key, is where you get your key deduction from. The guardians. It just feels like there's so many 9 guardians here. I'm not sure how to deal with that. Plus the fact that we already know these two contain a 9. So proving that doesn't help. Something I'd love to do is prove that one of these two needs to be 9. That makes a 1, 2 pair in here. I feel like that would be helpful. I'm not sure. Like, I'm trying to think like what would actually resolve everything. Like maybe this seeing a 9 could resolve the whole 1, 2 situation. So like proving this one has to be 9, like making an aagon loop that only involves this 1, 2, 9 and other 1, 2s. But I don't see how we would make such a loop. One thing I am noticing, which it feels built into Like these two 1-2 pairs feel built in, if that makes any sense. Maybe it has to do, I don't know, we know one of these is a 3, so it's not really that helpful. I was gonna say maybe it had to do with the 1, 2, 3s here, but huh. Where I don't see any other opportunities for Sudoku here. So where would each of these legs go? Right? Like if we need to make a loop, this is going to have to connect probably to here. So maybe we're doing something like this. That's 1, 2, 3, 4, 5. Six, 7. The problem is I can't connect to this one very easily. Maybe instead of what I just did there, maybe this goes all the way to the 2, 9. And then I can connect to here. So that's 1, 2, 3, 4, 5, 6. See, this would make an 8 length. 6, 7, 8. I'm just not seeing an opportunity for maybe 1, 2, 9s are a red herring. Like maybe I'm supposed to be looking at a different set of buy values. What am I seeing here? I don't really see any other like buy values of interest here. These are all buy values. It's kind of crazy. I wish I knew which one, like which 9s are we trying to prove here? It feels like that's what has to be happening, but so like, are we trying to prove that this one has to be 9, for example? Like if this was a 2, what ends up happening? We get the 1 here, the 2 here, we get the 1 here, we get the 9 here and the 1 here. This becomes a 2. So this becomes a 1. That's a 9. Three and 2. This doesn't feel like it's breaking. This feels like it's solving. So my hunch might be right that we're trying to prove that this can't be 9. That it's going to see a 9. Now what other 9? It would see a 9 in here, I suppose. So if this was the solution, let's look at what 9 does then. So a 9 here makes this a 1, 2 pair. That makes that a 9. It makes this a 1, 2 pair. And this a 1, 2 pair. So we end up with all these 1, 2s. Does anything else resolve, obviously? I mean, I could... See, I'm trying to avoid just, like, plonking too much here. But we end up with all of these 1, 2s. We also end up with this being a 9. So this would end up a 1, 2. This would end up a 4, so this would end up the 1, 2. So we have this 1, 2 pair here now. So we get all of these 1, 2s. And if we wanted to try to resolve them, let's see, 1, 2, 1, 2, 1, 2, 1, 2. Yeah, where's our aagon here? I guess it's from here to 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 here. How many nodes is that? 1, 2, 3, 4, 5, 6, 7. So let's keep that aagon there, and let's undo back to where I placed that 9. Okay. Let's highlight just these cells here. So this is an aagon for sure, because we've got 1, 2, 3, 4, 5, 6, 7. So this can't be bivalue colored. So that means one of these ends up a 9. Ah, okay. So if one of these 3 cells is a 9, might put those in purple. Let's clear out our line now. If one of the purple cells must be 9, then this cell cannot be 9 because it sees all 3 of them. So let's start with that. That makes a 1, 2 pair here, and that forces this to be a 9. Okay, and that proves that too, and now the rest of this should just resolve easily. Okay, let's get rid of the colors. So that's what we were looking for. In fact, let me just go back and let me explain this a bit more rigorously, just so that we're all on the same page here. So using the green highlighted cells, I can draw a loop from cell to cell, just like this. Now, this is what's called an aagon, because it's any odd length loop of cells, like what we've drawn here, is an aagon. And what we know about an aagon, if it's an odd length loop of cells, is that you cannot color it with just 2 colors. It's not 2 colorable. And that's the important thing, right? If I tried to use 2 colors here, like I could say, okay, let's actually get rid of all the greens. And I want to just use purple and orange, for example. And I want to two color it such that no row, column, or box contains 2 of the same color. Then as I move around here, you're going to start seeing what the issue is, which is that one of the nodes, no matter where we start, will always end up having no color available. So it would need to be some third color. So that's the important bit here, is that we cannot color the green cells with only 2 colors, which means there needs to be a third color somewhere. So that means that if none of these were 9, if none of these cells were 9, then this cannot be completed. One of these cells will end up empty, or we'd repeat a 1 or a 2 somewhere, because we can't 2 color this. If I were to try to do like 1, 2, 1, 2, 1, 2, again, what's this going to be, a 1 or a 2? No, neither. I need a third value, and I don't have one. So no matter where I start or what I start with, I'm going to run into a similar issue, where I'm not going to be able to go all the way around the loop. So what that means, what we've proven there, is that one of these 3 cells at least must be a 9. We need that third color to interrupt our aagon. So these 9s are called the guardians. And what you do is you go, okay, at least one of our guardians, the guardian of the aagon, at least one of our guardians must be true, or we break the puzzle. So one of these 3 is a 9. And all 3 of these cells that I'm going to put in purple again see this cell here. So if one of the purple is a 9, then this cell cannot be 9. If I put a 9 here, I end up with the exact aagon that I was trying to avoid. So this cell is not a 9, and that makes a 1, 2 pair, and that makes that cell a 9, making the guardian true. And now from here, I can just clear out everything, and it should just solve pretty easily. So there we go. That was the aagon I was looking for. It was hard to see, but by plonking digits for a little bit, I was able to fish it out. So there we go. That's 5. That's our 3. So this whole row should resolve. Yeah, we're literally just, since we're fully marked, we're literally just plonking digits at this point. So yeah, the aagon is a pretty neat structure. You can do it with bivalues like done here, and you can also do it with an odd length of strong links in general. If you just have an odd length of strong links, then you know that cannot be true. So cool. An odd length of not necessarily strong. They have to be strong links that also can't both be true. So you need basically exactly one of these two things is true, and you need to be able to make a loop, an odd length loop of exactly two things that can't be true. And if you can do that, then you've proven the puzzle's broken. So basically what you've done is you had to have basically said, well, then one of these has to be not true. And there'd be guardians to prevent that. So it's the kind of thing that's kind of a little bit difficult to think about, just because you have to first pretend the right thing that causes the aagon, which then you go, okay, the thing I pretended has to actually be true. Whatever I pretended wasn't true now has to, at least one of those does actually have to be true. So in this case, it was the 9s here. And as you can see, we actually ended up with 2 9s in those cells. It only had to be 1 based on the aagon that we found, but there we go. I know this solve was a little bit all over the place. I hope it was enjoyable regardless. I don't know if there was a simpler aagon to use, but I definitely found one. So I call that a success. Let me know how you did. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.